Okay, exact values from trig ratios. So, most triangles that have the same angles will have the same side values as well. They're all in the same ratio because triangles that have the same angles will all be similar in one way, shape, or form. What we're going to do is we're going to look at some specific triangles that actually have a value or share a value that is used in all of trigonometry. And they're the numbers that you're going to be coming to straight away and going, okay, that's what that is. I know what that number is. I know what, sine of this number is equal to. So what we're going to be doing is we're actually going to be coming up with what those trig ratios are, what those exact values are, okay? Now they're called exact values because if you were to put this into a calculator, you would come up with a number that is like it looks like a random bunch of digits, bar a few, but they've actually got some meaning behind them. So what we're going to do is we're going to start off by looking at, let's say we have a square, okay? And I'm going to draw this square straight, which is a good start. But with this one square, it's going to have a length of 1 on all the sides. Okay, so it's a square because it's all on length the same. Now what I'm going to do with this square is I'm going to slice it in half. Okay, like this. Now once I've sliced this in half, well, I'm only going to focus on one part of this triangle. One part of this square. So if I cut this square in half in the diagonals, okay, I end up with a part of a triangle that has 90 degrees here, and it has 45 degrees here, and it has 45 degrees here. We also know about this triangle is that it has two lengths here that are the same because those are the parts of the square, and we know that those parts are equal to 1. We can also find out what this third side of this triangle is by using Pythagoras, okay? So to do so, let's call it x is equal to 1 squared plus 1 squared. Okay, well x squared is equal to, well, 1 squared plus 1 squared is just 2. So x is equal to the square root of 2. So that means that this part in here is equal to the square root of 2. Okay? So we've got this triangle that's 1, 1, root 2, and it's got 45 degrees in both of the angles. So let's use the trigonometric ratios and find, well, what are the exact values that I would get if I were given a triangle that had 45 degrees on each of the other corners. So starting off with sine, so sine theta, well not theta in this case because the value that we're going to be doing is 45 degrees. Okay, so sine 45 degrees. Now it doesn't matter which corner you use for this one. Either one will work, but I'm going to use this bottom corner. So we remember that sine is the opposite over the hypotenuse. Okay, so we've actually got some values for this time. So the opposite side is this length here, which is 1, over the hypotenuse, which is the square root of 2. So sine of 45 degrees, okay, if you were just to type sine of 45 degrees into a calculator, you'd get a bunch of random decimals, as I said. But it's actually, in fact, that bunch of decimals is equal to 1 over the square root of 2. Or, if we were to rationalize the denominator by multiplying both the top and the bottom by root 2, it would be the square root of 2 over 2. Okay, and you can check that too. So you put sine of 45 degrees in and put 1 over root 2 or root 2 over 2 into your calculator and you'll see that those values are the same. Okay, sine 45 is not the only one we can work out from this one here though. We can also work out, well, what's cos of 45 degrees equal to, okay? So it's a similar sort of thing. I'm going to use green for this one. Okay, so cos is the adjacent over the hypotenuse. So the adjacent in this one is equal to 1, and the hypotenuse is equal to 2. So, again, cos of 45 degrees is equal to 1 on root 2, or square root of 2 over 2. Remembering that the ratio of cosine is the opposite over, or the adjacent over the hypotenuse. So the adjacent number, which is 1, over the hypotenuse, which is the square root of 2. Last but not least, or is it the last? Tan of 45 degrees. Okay, So this one's quite easy. The opposite is just the 1. The adjacent is just the 1. So tan of 45 is just 1 over 1, or which is just 1. So those are called the exact values for sine, cosine, and tan at 45 degrees. Those aren't the only exact values we know of. We also know of a few others that we can do. Okay, or we can use, I should say. So, if we were to look at these other ones. So, actually, before we do that, we also have a bunch of new ratios that we also have a bunch of new ratios that we can find what the exact values of those are as well. So, if we were to do cosec of 45 degrees, sec of 45 degrees. Remember, these are the trigonometric ratios, the inverse trigonometric ratios. Okay, so we've got cosec, sec, and cot, all 45 degrees. So with these, okay, we're going to do it the same way. So looking back at this triangle that I've completely decimated, or we don't even have to look at the triangle, in fact. We can do it both ways. We can look at the inverse of what we've got on the left, or we can just, not the inverse, sorry, the reciprocal of what we've got on the left, or we can use the triangle. So using the reciprocal on the left, I'm going to use red for this one. 1 over root 2 is what sine is, so cosec must be root 2 over 1, which is just root 2. That's it. It's as simple as that. And if you do it the other way too, it's hypotenuse on adjacent, remember? So here's my 45 degrees here. My hypotenuse is root 2, and my opposite, sorry, is 45 is the 1 over here. Okay, so it's not pointing at the angle, it's meant to be pointing at the sine. Okay, so root 2 over 1, which is just root 2. Turns out sec's the same. Okay, 1 over root 2, well, that's just root 2 over 1, using the reciprocal, which is just root 2. Okay, and 1 over 1, well, that's just 1 over 1, which is equal to 1. Simple. Okay, so this is for 45 degrees. So it's when we take a square and we split it in half. Okay, well, let's say we didn't have a square this time. Let's say, well, what if we took a equilateral triangle? No, it's not very equilateral, but we're going to take an equilateral triangle. Okay, and this time what we're going to do is we're going to split it down the center. Okay, like that. Okay, so take this equilateral triangle and split it down the center. I'm going to take this triangle out and work on it. Okay, so we know a few things about this triangle. Okay, and we can work some things out. We know that this angle down here, if I'm splitting it down the middle, it means it makes a perpendicular line with the base of that triangle. So that has to be 90 degrees in there. Now, an equilateral triangle, we know that all of the angles in here have to be equal to 60. Okay, so that means that this angle in here is equal to 60. But you'll notice that when I drew my red line in, I split the triangle in half, which coincidentally splits at 60 degrees, that top corner, in half as well. So, splitting it in half only gives me 30 degrees. Okay, so this is going to be the exact ratios for 30 and 60 degrees. Okay. We also know some values. We know that this length here is 2, so this time we've actually been given a hypotenuse. The base was split in half, remember? So half of 2 is just 1. And that leaves me with this unknown value here. Okay, so again, we're going to do some Pythagoras to work that one out. C squared is equal to A squared plus B squared. Okay, we know that the hypotenuse in this case is equal to 2. So it's 2 squared is equal to, well, my unknown variable, I'm going to call x. So x squared plus my 1, so my known variable, which is 1. So we get 4 is equal to x squared plus 1. Okay, subtracting 1 from both sides, we get 3 is equal to x squared. So x must be equal to the square root of 3. So this question mark in here is equal to the square root of 3. Okay, so there's my triangle. It's a 1, 2, root 3 triangle. Okay, so if you were multiplying that number up as well, you would come across a lot of different triangles that have 60 and 30 degrees, which would all share this unique or same ratio or relationship. Okay, so I'm not going to do the the reciprocal functions this time. I'll leave that for you guys to do. It's just flipping the thing anyway. What we will focus on though is we're going to do two different lots. We're going to do, okay, so sine 30 degrees. We're going to do cos 30 degrees. We're going to do tan 30 degrees. And we're also going to do sine 60, cos 60, and tan 60. Okay, so sine of 60 degrees, okay. Oh, sorry, sine of 30 degrees. So we're using this corner at the top, okay. Now sine is opposite over adjacent, so the opposite is 1. Opposite over hypotenuse, sorry. So the opposite is 1, the hypotenuse is 2. So sine of 30 degrees is just a half, okay. Cos, well, that's adjacent over the hypotenuse, so that's root 3 on 2. Don't need to simplify it. And tan, 1 on root 3. So 1 on root 3, or root 3 on 3 if you want to simplify that one. We don't typically simplify that one, but you know, it's there. You know how to simplify surds, and you definitely know how to rationalize the denominator. Okay, now when we do the 60 degrees, we need to focus on that 60 degree corner, and we're going to do the exact same thing. Sine opposite over hypotenuse, so the opposite is root 3. The hypotenuse is 2. So it's root 3 on 2. And you'll notice that, in fact, it's actually the same as this value here. Cos of 60 degrees is 1 on 2, so a half. And you'll notice that these ones are actually the same. Okay? And then tan of 60 degrees, well, that is root 3 on 1. Okay? Which is just root 3. Okay, so that one simplifies nice and easy. So those are the trigonometric ratios, the exact values of these trigonometric ratios. Okay, so the idea behind these is it quickly allows you to solve problems involving angles of 45 degrees, 30 degrees, and 60 degrees without actually having to use a calculator. As soon as you see cos of 45 degrees, you can replace that with root 2 on 2. Okay, and we will be seeing an example of that later on. But the idea is that now, instead of actually having to put these into your calculator and use them, you can just replace them with these known values. Okay? So with that being said, that's the exact values. Okay? And we will have a look in the next two videos at some examples.